Okay, so we're picking up where we left off. The first thing you want to do is look at your denominators individually and just see, is there anything that would cause you to divide by zero? In this case, there's actually going to be two things that would cause a problem. So you take each one and set them equal to zero and solve. So on the first one, -4 is going to be restricted, and then on the second one, -5 will be restricted. And so when you're doing your homework, after you put your answer, because we need to add these together, it'll ask you if there's any restricted values, and you'll just have like an x cannot equal, and it doesn't matter what order you put them in, just put a comma between them, and so you'll have a box for that, okay? But and this is important, it's important to find your restricted values, and this will be more obvious when we start solving these. Right now we're not solving because there's no equal sign. Right now we're just kind of practicing some algebra here. But what we want to do is we do want to add these together. And so we have to have that common denominator. Now notice I put them in parentheses, and I talked about this in a previous video, that it's all or nothing. They're together. X plus 4 stays together. X plus 5, they're together. They're their own factor. Okay, and so my LCD here is actually going to be X plus 4 and X plus 5. Okay, they're each their own little piece of the LCD here. So what I'm going to have to do here, and I'm going to try to color code this so we make sure this is all making sense here. I'm going to rewrite what I have here, but I'm going to give myself a little extra space, and you'll see why in just a second. So I'm going to have 3 over x plus 4 plus 6 over x plus 5. Now I gave myself a little extra room, because what I'm going to do here, and I'll do this in red, I'm going to multiply the first one by x plus 5 over x plus 5. So I'm introducing the first fraction, the denominator of the other one in this particular example, okay? And so now I have my denominators x plus 4, x plus 5. And then on the other one, I'm going to introduce an x plus 4 on top and bottom. I'm multiplying the top and bottom by x plus 4. And in doing so, now I have a common denominator between my two fractions. Now, they're in a different order, but that does not make a difference. X plus 4, x plus 5, or x plus 5, and then x plus 4. It makes no difference at all, whatever order you want to put them in. And then what I have to do, what's left for me to do on top, is go ahead and simplify this. So I'm going to have to add, and then I'm also going to have to distribute. So you'll notice here I want to distribute the 3 here, and I'm going to distribute the 6 here. You don't have to distribute right now if you don't want to, but I think I would, because if you don't distribute, what happens is students they'll make a mistake. Let me show you what they do. So let's see, we'll have 3 times x plus 5 plus 6 times x plus 4, and then all over my LCD, which it doesn't matter which one you put first. I'll just do x plus 4, x plus 5, okay? Doesn't matter which one I pick, they're equivalent. Now, the problem is I didn't distribute yet, which is okay, but when students don't distribute, what happens is they're like, oh, this is great. I can cancel this, and I can cancel that, and they think, oh, yeah, the answer is 9 apparently, right? And I can understand why you would think that, but we can't do that, okay? So that's not correct. And the reason why is because you have a plus right here, okay? So this is really the top. It's all one piece, okay? So it's either the whole thing or none of it because of that plus sign right there, okay? So what you want, so that's why I typically tell students, let's go ahead and distribute now. You have to be a little careful when it's a minus sign, and so we'll see that on the next example. But moving forward, I'll probably do the distribution early on, so I'll kind of be skipping a step to go ahead and get it out of the way. And the reason why is it's just very common that students will get to this point and they start canceling things out when they shouldn't. So, but if I distribute, then that kind of cuts down on those mistakes. So let's see, we'll go ahead and distribute the 3. So let's see, that'll be 3x plus 15. Distribute the positive 6, so that'll be a 6x, and then plus 24. And then that will all be over my x plus 4 and my x plus 5. Okay. Then on top, I do have some like terms that we can kind of combine, and then we'll see if there's anything else I can do, which I might be able to. So let's see, to save some space, we'll go ahead and take this and we'll go ahead and continue right here. So I'll have all this space down below, working from left to right. So let's see, I have 3x plus 6x. Let's see, that'll give me a 9x. And then I've got a plus 15 and a plus 24. So let's see, what is that? 39, I believe. So positive 39, so plus 39. And then all over x plus 4 and x plus 5. Now, remember, it's either all or nothing. So let's see, I don't have any common factor. Oops, there should be a 5 right there. I don't have any common factors. So it doesn't look like I can cancel anything out, but I'm not sure. The top is factorable. Now, if I leave it like this and nothing cancels out, that's fine. But to be safe, we should probably factor the top because they are 9 and 39 have a common factor of 3. So I'm going to factor out a 3, and that will leave me with 3x plus 13 all over x plus 4 and x plus 5. And I can't cancel anything out, so I am done. Now, since I wasn't able to cancel anything out, this answer is actually correct also, but I would suggest always, if you can factor the numerator at the end, go ahead and do that, just to be sure, And so I did that. I factored out a 3, and it didn't end up making a difference. I wasn't able to reduce, but you just always want to make sure you do that, just to be a little extra careful. All right, let's look at 43. Okay, so this one's kind of interesting. So I'm subtracting, which that will make things a little different. But let's see, I have an x plus 1 right here, and then I just have an x there. And you're like, oh, this one's just missing a plus 1. I'll just add 1 to the top and bottom. But that won't actually work. We can't do that. That would actually change the value of the fraction. You can't just add stuff to it. So think about this. If I had 1/2, and if I just were to add 1 to the top and bottom, it would become 2/3. It would become 2/3. If I just tried to add 1 to the top and bottom, it would not preserve equality, right? Because if I add 1 to the top and bottom, 1/2 is not the same thing as 2/3. So I can't just add 1. So I have to use multiplication. And before I do that, though, you should always look for your restricted values. And so my restricted values on this one, x cannot equal, just look at the denominators. You could probably do this in your head. What would cause this 1 to equal 0? That would be a -1. If you were to let x equal -1, what would happen is the first fraction's denominator would turn into a 0. That's not good. And then my other restricted value, looking at the second fraction, would just be a 0, because if you let x equal 0, the first one would be okay, but the problem is the second one would divide by 0. So those are my 2 restricted values, okay? So the way you want to do this is you look at your denominators. Are they factorable? The answer is no. If they're not factorable, then it's probably going to be the list of this together, unless you have some repeats, and I don't have any repeats. I have an x plus 1 and I have an x. They're different. The only way you have repeats is if they're the exact same, okay? They're not the exact same, they're different. So my LCD is just going to be the list of those. So it's going to be x, and it's going to be x plus 1. It doesn't matter what order I put them in, but it looks a little bit nicer to put the x first and then the x plus 1, okay? So once again, I'm going to go ahead and color code this a little bit to try to make this a little bit easier to see. So let's see, I'm going to have 3 over x plus 1. I don't need that big. Okay, minus 3 over just x. Okay, so I haven't done anything yet. That's exactly what I have above. But what I'll do is on the first one, I need an x as part of my denominator. So I'll go ahead and multiply the bottom by x. So I have to multiply the top by x. It doesn't matter if I put the x in front or behind the 3. I just prefer it right there. Okay. And then when I look at my second fraction, I'm missing the x plus 1. So I'll go ahead and multiply the top and bottom by x plus 1, right? Okay. And so now we're ready to go ahead and bring this together as a single fraction. Now you can write it, we could write it as 3x minus 3 times x plus 1, which is fine, but I kind of mentioned before I like to go ahead and do the multiplication now. Now on the bottom, don't multiply those, okay? And I guess I should have mentioned that on the previous problem. When the denominators, you'll never multiply those together, just leave them factored, okay? But on top, let's see, I have a 3 times x. That's pretty simple. That's just 3x. Now, this is where you have to be careful. I have to distribute the 3, but it's a minus 3, so you have to take that into account when I distribute it to the x and to the plus 1. So the minus 3 times x is going to become a minus 3x, and then the minus 3 times plus 1 becomes a minus 3. And then that's all over my LCD, which was x times x plus 1. And then on top, this is interesting. So I have 3x minus 3x. Well, those just are opposites. They cancel each other out. So 3x, take away 3x. Well, okay, you're gone. So all I'm left with is negative 3 over x times x plus 1. And that is my answer for 43. That's it. Okay. All right, let's do another one. Okay, so the first thing you want to do is look at the denominators and find the restricted values. And like I said, this will play a much more important role in a couple lessons from this one. Okay, so x cannot equal, so right here, this first one would be negative 2. Second one would be positive 2. That would cause me to divide by 0 if I used either one of those. Not good. Okay, once again, I'm going to kind of do the same thing I've done previously. I like this, just kind of writing it with a little extra space. And, you know, when you're doing this yourself, it is nice to have some different colored pens with you, or pencils, matte pencils or whatever. Have some just different colored pencils to work with and color code this, and it'll save a lot of heartache to kind of keep this organized, okay? And so once again, let's see, LCD, let's see. So the denominators are different, so I'm just going to list them. So nothing too crazy about this. And doesn't matter, I could have put the minus first and then the plus. Doesn't make a difference, okay? So on the first one, I'm missing the x minus 2, so I'm going to go ahead and introduce that x minus 2. On the second one, I'm missing the x plus 2, so I go ahead and I'm going to introduce that. Now, the denominators, don't multiply them together. Once you have your LCD, that's what the denominator is going to stay until the very end, unless you can reduce it, which we'll just have to wait and see. Now, what's different on this one than the previous ones is I'm going to have to FOIL this together right here on my second fraction. Not a big deal. We should be pretty comfortable with factoring at this point, okay? On the first one, I'm just going to distribute the 2x to both of these. So I'll go ahead and do that. So that will become 2x squared minus 4x. Okay, so I distributed the 2x to both of these. And then it's plus, and then I need to go ahead and factor this. Or, I'm sorry, FOIL this. So I'm going to distribute the x to both of these. So let's see, that'll give me an x squared plus 2x. And then I'll get another 2x for distributing that 2 now. And then a plus 4 on the very end. And then that's all over my common denominator. Okay. All right. So then the next thing we're going to do is clean up our numerator. So whatever like terms we have, we want to go ahead and clean that up. So let's see. I have a 2x squared here, and I have a 1x squared here. Let's change it. So let's see. 2x squared, a 1x squared. So that together is a 3x squared. Then let's see, this is kind of interesting here. I've got a minus 4x and then plus 2x plus 2x. So if you look at all three of those, they actually will cancel each other out. Because take away 4, then add 2 back, and then add another 2 back, and so they completely just nullify each other. And then we are left with a plus 4 on the back. And then all over x minus 2, x plus 2, okay? And then, you know, it's either all or nothing. You can either cancel out the top at the bottom or you can't. And if it's factorable, great. It's not. It's not factorable. It's not the difference of 2 squares because I have addition, not subtraction. So I can't try the difference of 2 squares. Even if it was subtraction, I still wouldn't be able to do that anyways. So this is going to be our answer for this one. All right, I've got one more slide of these. Okay, so this next one actually looks pretty similar to the one we just finished. Okay, so first things first, my restricted values. And so if you look right here, x cannot equal 5 or negative 5. Either one of those would cause me to divide by 0. And then the next step is look at my denominators. Just kind of ignore the top for a minute. And so they are different. So the combination of those is my LCD. So it's going to be x minus 5, x plus 5. And then once again, I'm going to color code this to kind of keep track of everything. So let's see, x plus 5 over x minus 5 plus x minus 5 over x plus 5. And so now I'll introduce the missing piece for each individual one to where I can have that common denominator. So on the first one, let's see, I got to introduce the x plus 5. And on the second one, I got to introduce the x minus 5. Okay. So what I'll do here on my next step is I need to FOIL this, FOIL that, and then don't worry about the denominators. That part's done. Don't overthink it. You're done with the denominators. You got them to match. So let's see, I'm going to need a little bit of room here. So let's see, when I FOIL the first one, let's see, I'll get an x squared plus 5x plus another 5x, sorry, because 5x and then 5x and then 25, okay? And we'll do the other one in a different color. And then the other one, we're going to have plus, I get x squared again, but this time I get a minus 5x minus 5x and then a plus 25. So, oops, I'm running out of room here. Let's see. Okay, I kind of move things around. I fit that plus 25 there. And then all over my common denominator, which is x minus 5, x plus 5. Okay, and so once again, don't start trying to cancel anything out yet. You got to see what like terms you have on top. And so let's see, we have 1x squared here, and we have another one here. So we've got 2x squares. And then all my x's seem to cancel out, actually. So let's see, a plus 5x minus 5x, plus 5x minus 5x. And then I have a plus 25, and I have another plus 25. So that'll be a plus 50, it looks like. Okay, and then that's all over x minus 5, x plus 5. Now, if you leave it like this, that would be correct. Okay, there's, you know, it's fine. But the top is factorable, and it won't actually make a difference, but it's worth investigating. So you factor out a 2, and I'm left with x squared plus 25, and then all over, let's see, x minus 5, x plus 5, and there we are. And so that's my answer. Actually, either one would work because once I factored, nothing canceled out. But as I said, it's just always good to take that extra step in case something does cancel out. Okay, this next one is going to be a little different than the others. I mean, it's going to be a very similar approach, but what's going to be different about it is that my denominators are factorable in this case. But before I even do that, well, yeah, let's go ahead and factor them because that'll actually make it easier to see my excluded values. So I'm going to go ahead and factor it, and then I'm also, at the same time, I'll leave some extra space so I can kind of get ready for my next step. So let's see, I'm going to have 3 over, I can factor out a 2, and that'll leave me with x plus 2. And I'm giving myself some extra space. I'm not even going to need that much space. And then let's see, plus 2 over, and then on this one I can factor out a 3. I'm left with x plus 2. So hopefully you can see that my restricted value is -2. I don't want to let x be -2 because if I do, my denominators would become 0, and that's not good. Now, as far as my LCD goes, I haven't had this situation happen yet, but we have it here. I do have a common factor involved. So that is part of my LCD, but I don't want to list it twice. You don't have to list it twice, okay, because it's there on each one. Okay, so let's look at the 2 and the 3 first. So the LCD between 2 and 3, or the LCM, is going to be, if we look between that, it's going to be, I'm sorry, I said that wrong. So LCD is going to be a 6, okay, because 2 and 3 divide into 6 evenly, right? 2 and 3. Or if you want to, you can take both of those with you and you multiply them together and it's 6, right? So somehow I'm going to have to make an adjustment to turn those into 6s. And then I already have the x plus 2, but that is part of my LCD. So that is my LCD right there, okay? So the only thing I'm worried about doing is I got to get that 2 into a 6, and I got to turn that 3 into a 6. And so this is actually going to be fairly simple. This isn't going to give me too much trouble. What I'm going to do here is I'll multiply the first one by 3 on top and bottom, and then the second one I'm going to multiply by a 2 on top and bottom. So I'm basically multiplying each one by 1, but in a way that will manipulate my denominator for me. So let's see, that will leave me with 9 over 6 times x plus 2 plus 4 over 6 times x plus 2. And so I have my common denominator. So now I'll do 9 plus 4, which is going to be 13 all over 6 times x plus 2. And there we are. All right, so I have one last one for us here. Okay, on this particular example, I can factor my first denominator right here. So we want to go ahead and do that, and then we'll list the excluded values. So let's see, this is going to be a 4 over, let's see, that's going to be x plus 3, x plus 3. You can leave it separate or you can bring it together as x plus 3 squared. Won't really make a difference in this particular case. And then my other one is 4 over x plus 3. So they're all x plus 3s. So I only have one excluded value, and that's going to be a -3. If you were to let x equal -3, you would have some issues here. You don't want to divide by 0. Now, as far as my LCD goes, this is kind of interesting. So what you're going to notice here is that I have x plus 3, and then I just have a single x plus 3. So this one's going to need the x plus 3 in order to match the other one. So that is what my LCD is. It's x plus 3, x plus 3, or if you prefer, x plus 3 squared, which, yeah, we probably should write it that way, okay? And we can do that in a minute. It won't count it wrong if you don't, but we just kind of want to get in the habit of recognizing that you can bring that together. So what I'm going to do here, I only have to manipulate one of these. The second one, I'm going to multiply by x plus 3 over x plus 3. So now I have those common denominators. Now they match, right? And so what I'm going to do over here, I got to distribute, it's a plus 4, so that's a good thing. Distribute that plus 4. I still have that 4 just sitting here, so don't forget about that one. So 4 plus 4x plus, let's see, what is that, a 12? And then all over my LCD, which this time I'll go ahead and write as x plus 3 squared. You want to keep it separate, that's fine, not a big deal. Okay, so what I have left here, let's see. So you want to go highest power first, so we'll put the 4x in front. And then 4 plus 12, let's see, that is 16. And then all over x plus 3 squared. Now, what we can do here on top is we can factor out a 4. It actually won't make a difference in the long run. It's not going to allow us to simplify anything, but we might as well go ahead and do that just to be sure. Okay, so x plus 3 and then squared on bottom. There's my answer. And this one would have been correct too. That's fine. But like I said, I just like to be careful and check everything out to see if anything will cancel, okay? Okay, so that's, this could probably feel a little overwhelming. If it makes you feel any better, so we got another one of these in my next video, and then the one after that, it kind of starts to get a little bit easier. Okay, so this is one of the harder sections of the whole unit. So if you feel a little overwhelmed, hang in there. It's not something that you pick up in one day, okay? So work a little bit on it now, a little bit later, tomorrow. Okay, so spread it out over time. If you try to get it all in one day, it's going to be difficult.